Let's start today. Tensor. It is very important chapter. You might be wondering that this chapter is, really difficult to understand. You might have confusion that I'll erase, eradicate, extirpate whatever the tension you have in your mind. I can kick it out of your mind within some days. All right. First, let's get started. Let's get started. Before starting this, I want to let you know that if you are new here, subscribe my channel. I have everything done for you. If you are from the mathematics background or physics background or economics background, you must know this one. That if you are in a data science, you must learn this. It tensor, you can see here I have written an introduction. The physical law must be independent of any particular coordinate systems. They do not depend on the coordinate system. Whatever might be the coordinate system, physical law, they do not depend on them. Alright, to describe them, if we want to describe any physical laws with respect to coordinate system, then this tensor might be one option. That if you are observing the same thing in a linear coordinate system and you want to change it to the curvilinear coordinate system or spherical coordinate system or cylindrical coordinate system, you can get, because you can transform it from one system of coordinate to another system of coordinate. All right, here you can see that if they are to be valid, that means these physical laws, whatever the quantity which follows the tensor laws, that means which does not depend on the coordinate system in which they are in, then this tensor might be good for you. That you should understand this before getting more information about the system. All right, here if you wanna get the physical laws or of any set of quantities together in any system, all right, here you are going to investigate behavior of the quantities. If you study the behavior of a quantity, you can understand the insight and the knowledge. Here you can see tensor are quantities obeying certain transformation laws. The certain transformation laws we have, these are followed by these quantities, which are called tensors. A tensor consists of a set of quantities called components. You can see many components. Also later what they are exactly in sometime later. All right, and whose property are independent of coordinate system in which they are in. No matter where you observe in any coordinate, they do not depend on that. Only your aim is to know the components nature. All right, components behavior, that means quantities behavior. At that time you must use this. All right, although we had many systems like curvilinear coordinate system, we like spherical coordinate system, cylindrical coordinate system. Just we are going to talk this right now about this curvilinear coordinate system. Let's see it together. You can see the r is a vector, which is going to represent in a three-dimensional mode. You can see x, y, z with respect to this these three the x-axis, and p is at this position. You can see the position vector p, and point p the coordinate transformation u1 equal to u2 u3. You may write this way. All right, and where u1 and u2 are curvilinear coordinates related to p. If you are in engineering, if you are in any the field of this technology, this might be the majestic, this might be your paramount role, pivotal role. This play paramount role, pivotal role for your work. All right, you can see here taking differential. the while you take the differentiation of this system of this r, the radius of this point P from coordinate, you can take with respect to u1, u2 and u3. You are taking a partial differentiation. You might have known this in your bachelor classes. All right, you can take the differential this way, and you are taking the full derivative, and for that what you are going to do, take the a partial derivative of each of this r with respect to u1, u2 and u3. You can get this equation. Then you may write this: the unit tangents are to the curve. These are the curve. These are the curve, and that means tangent. You can see your aim is to know that this is one curve, this is another curve, this is another curve. You are going to construct the tangent. All right, you can get a tangent which is touching to this curve. What would be the unit vector along a tangent? You can calculate this way. You can see here is cap u1's cap equal to del r vector divided by del u1 divided by del r. We have known that if we take the unit vector of any quantity, we should divide this vector by the magnitude of the same vector, then we can get the unit vector. That this is the unit vector of one curve. All right, and this is unit vector of another curve, this is unit vector of another tangent. You can get the unit vector of each one by dividing with their magnitude. If the vector is divided by their magnitude, would be the tangent, unit tangent. We have already know this. And if we try to cross multiply it, E into this is h1, the dr by du magnitude. Suppose you can take h1, then h1 e1 equal to dr by du. You can write here at same the way you did this one, you could do here at as well, and here you can do as well, or the same way you did for this too. All right, and then you can see where hi equal to dri dui. I means the coordinate, I means i's value you may write 1 2 3, and depends on what do you need. That means h1 equal to u1 and h2 equal to du2, and in this way you may go on writing. All right, how many given you have. In this way, from this equation 1, then equation 1 becomes, when you substitute whatever the value you got at here, the dr equal to h1 is power cap du. I have placed all value in the equation 1 in the place of this all one. You can get this equation. You can see, since del u1 is vector quantity at P normal to the surface, then u1 equal to e1, the unit vector in this direction. All right, u1 equal to u del u1 divided by magnitude of del u1, and similarly unit vector e del equal to e du, and in this way you can get the unit vector in all direction. You can represent in a capital letter of this e cap as well. These are the normal to the surface. The normal means unit vector along the normal, the tangent and the normal. You might have understand this your class 11 in a mathematics as well. And there is a tangent which is to the curve, and if we take the any line which is 90 degree with the tangent, would be the normal. If you are going to take the unit vector along the normal of this curve and the normal of this curve, then this might be your unit vector of the normal of that surface. And thus at each point of a P, curvilinear system exists in the general two sets of the unit. You can see here. And another one is, let's vector small e1 cap, e2 cap, e3 caps tangent to the coordinate curve, and capital e1 cap, capital e2 cap, capital e3 cap normal to the coordinate surface. The normal unit vector of this tangent, these are unit vector of the tangent, and these are the unit vector of the normal. And any vector A can be represented in terms of the base unit, or you can in the form, in this way you may represent, that you can write capital A1 is power cap, plus A2 is power cap, A3 is power cap, equal to A1. If you write in a magnitude form, small a1 capital is power cap, A2 is power cap, A2 A3 is power cap, where A1 A2 and A3 capital, and small a1 A2 and A3 are the respective component of the the A vector in each system. You are going to know the the whole system with respect to the each component in a x, y, and the z axis. Then from this equation 1, the when you write all this value u1, dr by du1 you have already calculated in this equation, and h as well was in this equation. So I substituted h1, you can see dr vector divided by d del u1 equal to this all vector. I have substituted from the value of this unit vector e1, e2, and e3, and you could get the unit like this. All right. And if you write the alpha I equal to dr vector del r vector divided by del u1, this is your general form. All right, general form means from which you can get alpha 1, alpha 2, alpha 3. If you write y, then that would be your normal one. Then vector A, when you represent in a simple form, you may write ci, because if you have a ci and you can have summation, you could get exact as same as you have seen here at. All right, here where C, I, Z are called the contravariant component of the A. Contravariant, you can see contravariant I and J, you are going to represent with I and J. All right. And Cj's are the contravariant component. And similarly, if you write this vector, that this is the vector A, you are going to represent in the form of a normal one, and you can represent this way. And whatever the way you can write, the same the way you may put it here. And Cj are called covariant component of A vector. That means covariant are the components of the normal unit, normal lines, the normal equation of the normal line to the curve. And contravariant means these components are the component quantities which represent tangent of the curve, the any system. All right. If you are going to represent tangent component of the tangent in x-axis, y-axis, z-axis, and your work is to know whole vector with respect to the tangent, you should use contravariant component. If you want to get the vector A with respect to the normal to the curve, you can see there are many curve r1, r2, and r3 you have seen there, and they are covariant, you can see covariant. All right. And these are where Cj's are called covariant component. In this way you may write covariant component and contravariant component of a vector. All right. And arc length, what would be the length of that arc? All right. And volume element and metric tensor, what are they? We are going to again calculate it in the curvilinear coordinate system. You can see the r is r1, this is the polar vector. All right. u1, u2, and u3, these three are the system you are going to observe. And if you take the partial differentiation of these three, of this vector with respect to 3, 1, you could get this way. You have done as same as in your equation 3 as well. In case of a contravariant component, you got this one, suppose. And if ds is the elementary arc length, you are going to know the elementary arc length means the distance, how much arc of the arc length in that figure you wanna if calculate, then you should multiply. That means you should have product of the dr, derivative of these two, and dr equal to, you can see here at same, dr equal to same. If we multiply, then we would have this way, that arc length. All right, and this would be, if we write this, and alpha I and alpha j equal to jgi and dui, you know the dui derivative of u with respect to j, you know the dj uj component. And here you can see gij equal to these two value. I have substituted at this place. All right, I have written this, and this place you can see here, and dj equal to dry dui and into del r vector duj is there. And this is fundamental or metric tensor, you know, that you can get from the value of the this, and this is, and the geometry I satisfying Euclidean in the 3D and the Riemann in the ND. In the matrix form, you may write here, and Gij has a G component in a 3D. You might have seen the 3 into 3 vector in your mathematics. You may write this vector, this component this way as well. All right, this is your system. If you wanna get the orthogonal coordinate curvilinear coordinate system, you can have this gij equal to hi square for I and j. For having the I equal to j value, all the value would give you a hi square value, and if the I and j are not equal, then whole value of the gij would be the 0 for this orthogonal curvilinear coordinate system. And if you substitute these two value, the equation, you know, the in this matrix, in the place of g1 g12 g13, you could have equation like this, and you may substitute it in spherical polar system. If you write this one, you know that this is for a coordinate system, or all right, coordinate curvilinear coordinate system. If you have coordinate curvilinear system, substitute this way to calculate g component. And if you calculate calculate gij in a spherical coordinate, polar coordinate, you put r square sin square theta. Now for this main diagonal, all other values would be 0. All right, and in the cylindrical system, you should write 1 c square 1 0 0 0. I have already told that our main focus is in this chapter to know the behavior of physical quantities, that means component, with respect to x, y and z in a one system. What was the system we described right now? We described the system curvilinear coordinate system. Hadn't we described the curvilinear coordinate system? With respect to curvilinear coordinate system, we can change these tensor value, these quantities, in a spherical coordinate system and in a cylindrical coordinate system. Therefore, tensor are the quantities, they are independent of the coordinate system in which they are in. All right, if we want to get their nature, then that would be our tensor. Tensor means these are the physical quantities which are independent of the physical system they are in, but we can observe them, we can study them in order to get some knowledge or insight of the system, to get new formula. All right, we can change them. Thank you. Tomorrow I'll do a lot more.